All right, Chapter 3, problem number 29. A diver runs horizontally with a speed of 1.2 meters per second off a platform that is 10 meters above the water. What is his speed just before striking? So we're given a horizontal velocity of 1.0 meters per second. We're told that the platform is 10 meters above the water. So that's 10 meters down, and we usually call down negative. So it's negative 10 meters. Now, the diver is accelerating, and he would be accelerating at 10 meters per second squared in the downward direction, and that's due to gravity. So that's negative 10 meters per second squared. And we're asked to find the speed just before striking. So we're looking for the magnitude of the final velocity. Okay, so let me draw a sketch of this to help you understand a little bit better what's going on. Okay, so here's the diver being displaced downward, delta y. The diver will follow a parabolic path because the diver is in free fall, accelerating downward at g. And we're asked to figure out VF. Now let me change this curve a bit so I can show you a better VF. Okay, it's going to be directed something like that, right, as the diver goes into the pool. So I'm going to start out by writing an equation for the final speed. Okay, I think they're looking for just speed, yes. So I'm going to use the Pythagorean Theorem, right? The final speed is equal to the square root of the diver's velocity horizontally squared plus the final velocity of the diver squared in the y direction. Okay, so that would be this velocity, that's the VFY, and then we have the VX, which is the same as what he leaves the board at. Now the other thing I'm going to put in the given information is that the original velocity in the y is 0. Because I need to find VFY. And I'm going to go to this equation, VFY squared is equal to VOY squared, where VOY is 0. So this term is eliminated, plus 2 times the acceleration due to gravity times the vertical displacement. So you can see by taking this equation here, okay, which is equal to the square root of Vx squared plus Vfy squared, and combining it with this equation, I'll get my answer. So I have to take this term, Vfy squared, which is equal to 2g delta y, and put it in under the radical for Vfy squared. Now hopefully you followed that. I could hardly follow myself, but just take a look at what I did. Okay, so you have VF is equal to the square root of Vx squared plus Vfy squared. This expression will get me Vfy squared. Vfy squared is equal to Voy squared, which is 0, plus 2g delta y. So I'm going to take 2g delta y and put it in for Vfy squared. So here we go. Okay, now I will put in the given information, the numbers. So velocity in the x is 1.2 meters per second. Square that. 2 times the acceleration due to gravity, so we have 2 times negative 10 meters per second squared. And last but not least, delta y is negative 10 meters. So I just took 10 times 10 times 2, okay, 200, and I'm going to now square 1.2, 1.44, add that to 200, take the square root, and I get 14 meters per second. So the diver strikes the pool hopefully not the concrete, at 14.2 meters per second.